Welcome to The Explainer. If you're the kind of focused learner who loves reverse engineering the actual source code of reality, you are in exactly the right place. Today, we're diving into a totally mind-bending shift in geometry. We're talking about abandoning that old school continuous math and stepping into a bit-perfect, discrete reality. Imagine swapping out those invisible, ghostly points for actual, tangible geometric surface regions. It's wild.
Okay, let's dive into this. Here's our step-by-step roadmap for unraveling all of this. 1. Escaping continuous gunk. 2. The cork and halting. 3. The diamond tile spiral. 4. Cardinal alignment of squares. 5. Parity and oblong numbers. And finally, 6. A new discrete reality.
Section 1. Escaping continuous gunk. Before we get into the new stuff, we have to talk about the biggest hurdle in legacy mathematics. And it starts with a question I want you to really think about. Is space a continuous fluid that you can zoom into forever, or is it actually made of discrete, indivisible pixels? Stephen Wolfram has this great analogy. You look at water, right? It looks perfectly continuous. You feel like you could divide a drop of it infinitely. But actually, we know that's not the case. It's made of discrete molecules. You either hit a water molecule or you don't. So what if the fundamental geometric fabric of space operates the exact same way? This sets up a massive clash in how we view the universe. On one side, you've got legacy points at calculus. This old model treats the world as this continuous grid made up of zero-dimensional ghost points. But since they have literally no physical size, they're just abstract concepts, hallucinations, really. We call this infinitely divisible, completely undifferentiated space gunk. Yeah, gunk. On the other side, we have this elegant alternative, mereological manifolds. Now, mereological is just a fancy word for the study of parts and wholes. But in this model, space isn't made of invisible dots. It's built from finite, discrete surface regions, actual physical tiles. So why ditch the math we've been using for centuries? Well, because it creates a crisis of infinite hallucinations. Look, when your whole system is built on zero-dimensional points, you can divide any space forever. You literally never hit a bottom floor. And this creates what physicists call uncomputable xenodrift. It's basically a computational nightmare where algorithms fall into this infinite gravitational well of fractions. They get closer and closer to zero, but they never ever actually halt. Let's move to and see how this builds into Section 2, the cork and halting. To fix this crisis of gunk, we desperately need a physical way to stop the infinite zoom. And that brings us to the cork. In this discrete framework, the absolute center of our coordinate system isn't some invisible dimensionless origin point. It's an actual, tangible physical surface area. Mathematically, it's defined as z equals 0 and d sub 0 equals 1. Think of it like putting a physical cap on the bottom of a microscope. It establishes a fundamental unit of resolution. It literally stops those infinite precision hallucinations in their tracks, basically saying, right here, this is where the division stops. So the absolutely crucial takeaway here is that by anchoring everything to this physical cork, we achieve something amazing, deterministic halting. We pull our computations out of that endless freefall of continuous gunk, and we turn them into bounded, bit-perfect steps. Every single calculation finally has a definitive end. We finally have a solid, bit-perfect bottom floor for reality to actually stand on.
All right, building on that, Section 3, the diamond tile spiral.
And this brilliantly illustrates what happens when we zoom out. Now that we've secured the micro-level bottom floor with the cork, let's look at the macro-level architecture of reality. Forget the old-school graph paper with its rigid X and Y lines. In this new model, space is mapped out by a symmetric diamond tile spiral, a continuous, outward rippling wave of discrete triangular tiles. Now, these aren't just decorative shapes. These are functional mathematical primitives. This is our mereological foundation. Space is constructed entirely from these discrete triangular regions, our tiles. Think of them as sovereign physical objects. And as this spiral expands, it follows a strict 16-phase lattice. That means there are exactly 16 distinct rotational states, or spokes, shooting outward from the center. By addressing these physical surface tiles one by one, we completely bypass that continuous point set. Space literally becomes a functional succession of states. Which brings us to something truly awe-inspiring. Section 4, cardinal alignment of squares. Just by organizing space as this discrete spiral of tiles, hidden geometric proofs naturally start bubbling up to the surface. It is so cool. Let's look at perfect squares. Numbers like 4, 9, 16, 25.
Now, in our spiral, every tile has an integer address, z. We just count them as they spiral outward. So the big question is, where do the perfect squares, z squared, actually land in the setup?
Well, they definitely don't land at random. The source material maps out 16 highly specific forensic spoke phases, and when we distill all that dense data, an unbelievable pattern emerges. On spoke 8, which points straight west, we find all the even squares, 16, 36, 64, 100. Then on spoke 12, pointing east, we find all the odd squares, 9, 25, 49, 81. The perfect squares are literally sorting themselves out automatically along the horizontal cardinal axes. If you picture the white tiles from the spiral we just discussed, those white tiles actually form this cardinal horizon. And the perfect squares land with bit-perfect alignment exclusively on those white tiles. It's absolutely not a coincidence. This cardinal horizon is undeniable, visual, geometric proof of a binary power law expansion hiding right there inside the discrete manifold. The surface math is naturally resolving the powers of 2 all by itself.
But wait, it gets even better. Section 5, Parity and Oblong Numbers. The mathematical revelations don't stop with squares. Let's pivot to the vertical axes and check out another massive hidden structure. Let's talk about oblong numbers. Algebraically, that's n times n plus 1. Numbers like 2, 6, 12, 20. So, if the perfect square is locked in flawlessly on the east-west horizontal plane, where do you think these oblong numbers are going to land?
Now, what's really interesting about this is the oblong partition. The spiral literally sieves the oblong numbers perfectly along the alternating south-north spokes, and it does it based purely on their parity, whether they are even or odd. So the vertical dimension acts as this natural mathematical filter for oblong numbers, while the horizontal dimension catches all the squares. It's definitive proof that the geometry has a perfectly balanced cardinal distribution built right into its core structure. Let's bring it all home. Section 6, a new discrete reality.
Okay, so we have these mind-blowing mathematical alignments, but how does this actually connect to the fundamental physics of reality? Well, it works because the rule scales flawlessly. Picture the massive macro spiral expansion we've been talking about and compare it directly to the micro-internal partition of a single unit cell. That single cell is a Turing cell, complex enough to handle computation entirely on its own. The exact same bit-perfect rules governing the cosmic spiral are the same rules governing the internal subdivision of the microscopic tiles. The macro and the micro reflect each other, seamlessly, without ever overlapping. And the whole shebang is secured by these strict boundary conditions. The 16-spoke sequences actually map out the vertices and edges of a rational octagon. This octagonal boundary replaces all those messy, continuous circles and pi approximations from legacy physics. It ensures every single spatial address is locked safely inside a bit-perfect geometric frame. It literally secures the manifold and stops that chaotic drift you always get with traditional polar models.
So, why does this matter for you and me? Why should we care? Because this is not just some abstract math puzzle. This is the stable, bit-perfect substrate that is absolutely required for real quantum mechanics and error correction. It guarantees deterministic halting. It secures quantum state stability. It puts an end to agentic Naperian drift, so geometric identity doesn't just blur out over time. And it completely eliminates uncomputable irrational geometry from the very foundation of physics.
I'm going to leave you with this to ponder. If reality doesn't just zoom in forever like a continuous blur, if it fundamentally halts at a bit-perfect physical surface tile, what incredibly stable, infinite context architectures can we finally build on top of this true discrete foundation? The possibilities for computation, for physics, for our entire understanding of the universe, they are absolutely endless. Thanks so much for joining me on this deep dive in today's explainer, and keep exploring.